Dude over here looking at another exam question, so let's have a quick look. Life insurance fund has assets of 600 mil on the 1st of Jan 03. We get 40 mil on the 1st of Jan 04, 100 mil on the 1st of July 04, and it tells what the value was before we get our 40 mil, before we get our 100 mil, and then at the end of, I guess, 2 years have passed, 800 mil we get over there. So it wants to know for that time to 3 decimal places, what is the time weighted rate of return? Okay, so easy enough to work out. Let's actually just do a timeline over here just to see how things look. So 1st of the 1st 03, we started with 600. Then in a year's time, it was the 1st of the 1st 04, and we received 40. And just before then, 450 was the value, so we'd lost some money. Then 1st of July 04, we received 100. Just before then, we had 500, so it went up a little bit. And then at the end of the year, 31st of the 12th, 04, we end up with, it's 800, yeah. So there we go, that's how it all looks. And internal rate of return, not the internal rate of return, the time-weighted rate of return, 1 plus I squared, is equal to, and so 600 turns into 450, so we start off with 600, we end up getting 450, so that's not good, we've lost 25%. Then we've got 450 now. We're going to add on, we've just managed to get out 40 million from somewhere, and that's then going to turn into 500. So we're going to increase it by 10. And then we're going to have our 500. We somehow score an extra 100, and we manage to do really well and turn that into 800. And now all we have to do is find out what I is equal to, so let's use Excel to work that out to 3 decimal places, let's remember. So that's equal to 450 divided by 600. Then we've got 500 divided by 490, and then we've got 800 divided by 600. We find the product of all that, and then we've got to put it to the power of a half and minus 1. That to the power of a half to get rid of the squared, that minus 1 to get rid of the 1, and we get 1.015%. Okay, 1.015% per annum. There we go. Not such a great score for 2 years' work. Then, the linked internal rate of return using subintervals of a calendar year. Okay, specifically, so we're only going to be doing 2 years over here. So, our 1 plus our linked internal rate of return, that's going over a 2-year period, is equal to our rate, for the first year, number 1, and we're multiplying that by our rate of the second year. Okay, and that's all we're doing. So for the first year, our 1 plus I, that was equal to 450, so 600, 450 divided by 600 is going to be how much we get, and our 1 plus I is going to be equal to 0.75 as we saw before. The next bit, and that's number 1, by the way. The next bit is this part over here. How do we figure that bit out? So we'll get to that. What we're going to do is, we're going to be, in order to find this, we start off with 490, sorry, I should show up here, 490 over here is what we start off with, and then that's going to be invested, and for 1 year we're going to be earning that interest rate number 2, and then 100 we're going to be getting, and that's going to be invested for half a year at our interest rate number 2. So that's going to be 1 plus I 2, it's going for a full year, plus we got 100, and that's going to go to 1 plus I 2, but only for half a year. And that's all going to equal 800. So now we can try and figure out what 1 plus I2 is equal to. So over here we can just let 1 plus I2 to the half be equal to x, just to make things easier. So then, and I'm also going to divide everything by 10, just to make things a little bit easier as well. So I'm going to say 49x squared plus 10x minus 80 is equal to 0. Okay, and now we can just use our quadratic formula to figure that out, which is negative b plus minus root b squared minus 4ac, negative 10 plus minus root b squared, which is 100, 10 squared, minus 4 times a, which is 49, times c, which is negative 80, and that's all divided by 2a, 2 times 49, and that's going to be equal to x, which as we know is equal to 1 plus I number 2, all to the power of a half. Okay, so let's use Excel to figure that one out. So is equal to negative 10, let's start with plus the square root of 100 minus 4 times 49 times negative 80, all divided by 2 times a, which is 49 over there, and then we get 1.17978. So let's just see what happens if we put a minus there, even though I can almost guess what's going to happen. Yeah, that's not a number that we want to be looking at right now, so we can get rid of that, and we only want to use this. So 1 plus I2 to the half is 1.1797. Okay, so 1.1797, I think there was an 8 there. And now in order to find out what I2, we just square it and then minus 1. So let's just square it because we don't need to minus the 1. Comparative, so this is our 1 plus I2, and as we see over here, 1 plus I2 is fine. Now we have to multiply by 1 plus I1, and we'll get this bit. So 1 plus I2, I'm just going to do 1 plus I2, 1 plus I1 is here, and this was equal to 0.75 as we saw, so we just find out what they are multiplied by each other, and this is our 1 plus the length internal rate of return squared. So we put it to the power of a half and minus 1 to get our value. That to the power of a half, that minus 1 is equal to, and that's 2.172% to 3 decimal places. Alright, so let's write that down right over here. LIRR is equal to 2.172% per annum. There we go. So that's looking alright. And what was the final question then? It said, explain why the linked internal rate of return is higher than the time-weighted rate of return. So this is 1%, just a bit above 1, and this one is a bit above 2%. So what happens is the linked internal rate of return uses the money-weighted rate of return. And what happens in that one of the flaws there is that when it weights it towards when there's a lot of money in the fund. So over here is where the most amount of money is, and so it's going to be saying, oh, if this is a good performance, then on the whole we think we did really well. But in actual fact, it hasn't thought that for a whole year we actually lost 25%, so it's skewed towards this end of the spectrum, and that's why the linked internal rate of return is actually going to be higher than the time-weighted rate of return in this case. So if you have any questions, please ask, but thanks a lot for watching.